Okay, chapter probability and section counting. So in this section, we're going to talk about permutation and combination problem. We're going to talk about a couple of formulas and five different methods for solving counting problems. Okay, eventually these methods will provide a strong foundation for most common real application problem. So the first one, multiplication counting rule. For a sequence of events in which the first event can be occur n1 ways, the second can occur n2 ways, third one can occur n3 ways, and so on, the total number of outcome is product of all those different ways. Like in this case, it's a n1 times n2 times n3 times. Keep multiplying those outcomes. That's the first multiplication counting rule. Factorial rule. In this section, we are introducing this symbol called factorial. This is a symbol we use, and the number of different arrangements where order matters of n different items when all n of them are selected is n factorial. So what is n factorial actually? So n factorial is, it's the multiplication starting from the whole number n times the next number n minus 1 times n minus 2. Keep going until you get 1. So there is one thing you have to keep in mind. For the factorial symbol, 0 factorial is equal to 1. Okay, 0 factorial means 1. That's how we define 0 factorial. The factorial rule is based on the principle that the first item may be selected n different ways, the second item may be selected n minus ways, and keep going like that. This rule is really the multiplication counting rule modified for the elimination of one item on each selection. That is how we have this formula. Okay, for example, if you have to find out 5 factorial, it means multiply starting from whole number 5, the next whole number 4, 3, 2, and 1. So that is the value of 5 factorial. Permutation. Permutations of items are arrangement in which different sequences of the same items are counted separately. For example, let's say how many different ways we can arrange a word from letter A, B, and C. Then you can write down that word as ABC or BAC or BCA. These are the different though you can see that the letters are appearing, ABC are appearing in each of this word, but because of their order, they are assumed to be the separate words. So permutation of items are arrangement in which different sequences of the same items are counted. So when we make a word start with the ABC, then ABC, BAC, BCA, they counted as a different word for the permutation. Combination of items are arrangement in which different sequences of the same items are counted as being the same. So we don't care about either A comes first or in the middle or last. For us in combination, ABC, BAC, and BCA, they count as a one single word. So combination of items are arrangements in which different sequences of the same items are counted as being the same. The later arrangement of A, B, C, AC, B, B, AC, BC, AC, AB, and CBA are all considered to be the same combination. Okay, for the combination. Remember, permutation position matters. In combination, position doesn't matter. So this is how we can remember permutation position, where the alliteration reminds us that with permutation, the position of the items make a difference. Remember, combination committee, which reminds us that with the member of a committee, rearrangement of the same members result in the same committee. so order does not count. This is how we can remember permutation. Position matters in permutations, but position doesn't matter in combination. So there is a rule or formula for finding the permutation. When n different items are available and r of them are selected without replacement, the number of different permutation, keep in mind order counts, is given by this formula n, choosing r from n many. That's the permutation of formula, which is n factorial over n minus r factorial. Permutation rule. There is another permutation rule. When some items are identical to others, the number of different permutation, keep in mind in permutation order counts, when n items are available and all n of them are selected without replacement, but some of the items are identical to others, is found, then we can use this rule as a permutation rule, which is n factorial over n1 factorial, n2 factorial up to nk factorial, where this factorial down here, n1 are alike, n2 are alike, nk are alike. So this many, so if you see some of identical, then you have to divide by that factorial for a permutation rule. So for example, let's say I'm going to explain about this example, this formula here, one example. When designing survey, pollsters often repeat a question to see if a subject is thoughtlessly providing answers just to finish quickly. So for one survey with 10 questions, 2 of questions are identical to each other. So 2 questions are same, but there are 10 questions with superficial difference in wording, and 3 other questions are also identical to each other. For this survey, how many different arrangements are possible? So if you don't have this identical, then you can say that, okay, how many different ways we can create 10 questions, in 10 factorial ways we can create 10 questions, right? So because first question can be chosen in 10 different ways, next question can be chosen by 9 different ways, and 8 different ways, keep going. That will give you 10 factorial ways to create 10 questions without this identical restrictions. But now we have given that 2 of the questions are identical and 3 of the other questions are identical. Now we can use this rule. How many different ways we can create the question? That is 10 factorial divided by 2 factorial times 3 factorial, because 2 questions are identical and 3 other questions are identical. So 10 factorial divided by 2 factorial times 3 factorial, that gives us 302,400 different ways we can make that 10 question. Interpretation. There are 302,400 different possible arrangement of the 10 question. It is not practical to accommodate every possible permutation. For typical survey, the number of responded is somewhere around 1,000. Okay, here is the next rule for the combination rule. When n different items are available but only r of them are selected without replacement, keep in mind for the combination, order does not matter. Then this is the formula we're going to use for combination, which is n factorial divided by n minus r factorial times r factorial. Okay, so we are going to see a couple of we're going to do a couple of examples from this section. Look at the first problem. What does the symbol factorial represents? We already know that factorial means it's a number. Now we are multiplying the number starting from this number, whole number, going up to 1. So to answer this question, the symbol factorial is the factorial symbol. It represents the product of decreasing positive whole number. Yeah, the first option is the right one. Okay, what is 5 factorial then? We already found the 5 factorial, which is actually 120. So I can just plot that 120 here. Okay, so let's look at another example. A thief steals an ATM card and must randomly guess the correct 4-digit PIN code from four keypad. So there are four key, and a thief has to randomly guess 4-digit pin code. So in this problem we can see that there are 4 digit, 1, 2, 3, 4, and then for each of them there are 4 possibility. If you read the question carefully, repetition of digit is allowed. So for the first digit there are 4 possibility. Because repetition is allowed, for the second one there are 4 possibility, third one there are 4 possibility, and fourth one there are 4 possibilities. So altogether it's a 4 times 4 times 4 times 4, which is 4 to the power 4. Okay, and if you try to find out this number, 4 to the power 4, 4 to the power 4 is equal to 256 different ways. So the number of possible code, there are 256 different codes. The probability that the correct code is given on the first try is, out of this 256, only one of them is the right answer. So the probability is 1 out of 256. In this part we can use integer or fraction as answer, so 1 over 256 is the right format. When testing for current in a cable with 12 color coded wires, so there are 12 color coded wires, the author used a meter to test 5 wires at a time. How many different tests are required for every possible pairing of 5 wires? So in this problem, if you look at the problem here, there are 12 wires, right? There are 12 wires, and where is that? There are 12 wires. Out of 12, we need to make a group of, how many? 5 wires. So now, in that wire group, 5 wires. So the repetition, if you have the repetition, that is the same meaning, because how many different ways you can make those groups. So repeated group means same thing. So it's a combination problem. So you have to choose 5 out of 12 formula, which is 12 factorial over 12 minus 5 factorial times 5 factorial. That is the combination formula. N, r chooses from n is n factorial divided by n minus r times r factorial. So in this case it's a 12 minus 5. So I'm going to calculate this here. 12 factorial means 12 times 11 times 10 times 9 times 8 times 7 factorial divided by 12 minus 5 is 7 factorial. 5 factorial means 5, 4, 3, 2, 1. You can cancel this 7 factorial and you just have to divide this number by this number. So I can just cancel 5 times 2 is 10, 4 times 2 is 8, 3 times 3 is 9. These 2 and these 2 cancel out. So the number of tests required is 12 times 11 times 2 times 3, which is, if you multiply these numbers here, 12 times 11 times 3 times 2. Let me double check here. 12 times 11 times 2 times 3. So that many tests required, 792. The number of tests required is 792. That many possible case. Okay. Which of the following is not a requirement of the permutation rule? This is the formula for the permutation. Order is not taken into account. Okay, in permutation, order should be taken into account. So this is not the permutation rule. Okay, let's take another one. Which of the following is not the requirement for the combination? The order is not taken into account. That's right. That there be n different items. That's right. The order is taken into account. For the combination, order doesn't matter. So finally, fill in the blank. If the order of the item selected matters, then we have a permutation problem. That's a permutation problem. So these are some rules you have to understand from this section, permutation and combination.